Hi folks, I've had several subscribers show interest in my Panasonic audio analyzer. That's this big guy right here. It's a Levere VP7725D. Now, Levere, I believe, bought out Panasonic's measurement division, and this is a later model. But if you do a search on the Panasonic VP-7725, you'll get this thing. Now, why did I buy it? Because I'll tell you the truth, that one piece cost more than everything else on my bench combined. And the reason I bought it is because of the law of diminishing returns. And believe me, that applies to test equipment doubly. This will read distortion down to 0.0001%. That's 3 zeros behind the decimal. And you pay for that. You pay dearly for it. Now, before that, I was using a Keithley 2015 THD, which is a great instrument because it's a full-featured 6.5 digit multimeter with great specs, reads AC voltage up to 100 kilohertz, so it's great for audio work. But the Achilles heel is the onboard sine wave generator. It is not low enough in distortion, and I'm going to demonstrate that here shortly. The general rule of thumb with test equipment is you want your test equipment to be 10 times better than whatever you're measuring. And I started seeing amplifiers that had specs of 0.05%, and the Keithley just wasn't cutting it for that. I looked also at some of the other more traditional instruments like the HP 33X series. And while they're good instruments, they also don't have the kind of specs that we're looking for. So I bit the bullet and bought this and was really unhappy when the oscillator section died. Fortunately, as I've mentioned, one subscriber here, Pack1085, liked this unit so much he went out and bought 2 of them in a package deal on eBay. And he got one that was damaged, and long story short, he sold that to me, for which, as I always say, I am eternally grateful, and thank you once again. So I'm going to show you some of the features of this instrument, how to use it, some of the good points and bad points, because everything has them. And, well, let's go take a look. All right, so here's the unit. You can see we have a set of numeric keys here. We have our function keys that select what these digits will affect, and then we have our units keys. So for instance, if I was in frequency and I hit 1, look over here, kilohertz, I'm going to get a 1 kilohertz output from my oscillator. Conversely, if I go amplitude and I go 1 volt, I will get a 1 volt AC signal out from my oscillator. So these have multiple functions depending on what we are. If we're in frequency, we're going to have these keys active. If we are in amplitude, we're going to have these keys active. And if you can see the labels, we have kilohertz, hertz here, we have volts and millivolts here. We have ohms here for setting the load of our input. And I'll turn this on so you can get a better idea. We have a set of soft keys whose function is dictated by the menu that appears on the right here in the menu. We also have our source measurement menu, our filters. We have memory storage, memory recall. Well, I do use that on my oscilloscope. I don't use it on here. And we have our system, which is your global settings. We have our auto range, and this is one of the things that screwed me up, and we'll talk a little about that later. And we have our hold. Our digit selector allows us to select our MSD or LSD. And when I say LSD, I'm not talking about the popular hallucinogenic. I'm talking about the least significant digits. So if we have 100, our least significant digit would be the right-hand 0. The MSD would be our most significant digit, and it would be the 1. So I'm going to turn this on, and of course it's noisy like everything else in here. Everything in here has a fan. And you can see it comes up with our display. Now I have it set for THD. We can just measure distortion, which is THD plus N, or we can measure straight THD. Now THD plus N is what most other distortion analyzers measure. It's the easiest measurement to make. You're measuring distortion plus any noise component, for instance any 60 cycle hum. It's a little tougher to measure strictly THD without the noise component, but that's generally what most of our equipment is spec'd out in. It's what we're going to use. So I leave this unit in THD. If I want to measure just distortion, we change it to here. If I hit shift distortion, we get our THD. If we go source, we can select whether we have channel A, channel B, if they're unbalanced, or we can combine A and B, which I really rarely do because I'm working on stereos and that's what we use here. Our measurement brings up this soft menu here. Our RL is the resistance of our dummy load, and if I hit this, you'll see it comes up with 8. If I put in 4 ohms, now we have a 4 ohm dummy load, but since mine are 8, we are going to use 8 ohms. And you see how the key was blinking? So if we want to do a frequency for our oscillator output, we hit 1. You see how these keys are blinking? This is hertz and kilohertz. These keys are not active. They won't do anything for us. So if I want 1 kilohertz, I hit 1 kilohertz, and that is our frequency, and that will appear up here in the display. If I go to amplitude, and I go 1, and all 4 of these light up because we can go dB, volts, dB millivolts, volt, or millivolts. So I'm going to go 1 volt. I don't think I was quick enough there. 1 volt. Now we have 1 volt output. This turns the oscillator on and off. And if I want to edit the amplitude, I can use my digit selector. And if you can see, we have an outline here. Every time I press it, it scrolls through. There's our most significant digit. There's the one next to it. If I go down here by 1 click, now we're at 900 millivolts. I select 900 and I can just go 100 millivolts at a time, or I could choose to go 10 millivolts at a time. So that's a handy feature. Most of these features are handy. And one I said which can be a double-edged sword, is very convenient but can catch you if you're not paying attention, is the auto range function. Now, I have seen, because this unit has 2 outputs on the back to connect to your oscilloscope, where I think I have a signal, but it's such a low signal it doesn't really count. You wouldn't hear anything connected to a speaker, but you will see a sine wave on the scope. So that's a bit of a problem, and I have to always be aware of that. And I've been caught out more than once. You've seen me on the videos. So that's a feature that can also turn around and bite you if you're not careful. Okay, so I think I mentioned this turns your oscillator on and off. This is your frequency, amplitude. Now your soft keys change depending on what we're looking at. If we go to filter, it gives us all these different types of filters. Generally speaking, I leave my low pass filter on. It begins to roll off after 80 kilohertz. Most distortion analyzers have a default filter set like that. Now, the other thing I want to do is I'm going to turn the Keithley on, and we're going to take a look at that. And I'll show you what the Achilles heel is here. Okay, so here's our Keithley 2015's THD. I know the meter above it looks like the same thing if you take a look, but I can assure you it does not have the distortion functions. So we're going to just concentrate on this one. So if I hit my source button, this brings up my sine wave source, and it defaults to off. So we take our right hand key, we turn this guy on, we enter to go to our next parameter, and I'm going to put out 1 kilohertz. Well, here's the problem. That's 0.1 kilohertz. This is what happens when you don't pay attention. Okay, there's my decimal, a little hard to see. At my age, everything's a little hard to see. So we go to our next parameter, 50 ohm output, amplitude 0.5 volts. Okay, we're not worried about channel 2, so we exit now, and we should have output coming from the back. I keep a BNC cable there. So let's go back and take a look at our analyzer and see what this guy looks like. Okay, so I have the analyzer here set to read out volts. Now I usually leave it in watts because I'm looking at the output of my dummy loads, and we're going to talk a little bit about how those are connected as well. But I want you to take a look at the output from the Keithley. Well, that isn't going to work. I need to put on the input. And there we go. Now you notice I set it for 500 millivolts, but we are showing about 1 volt. That's because this is unterminated. We set the Keithley for an output impedance of 50 ohms. So if I fed that through a 50 ohm feed through, we would see that would read a half a volt instead of a volt. But we don't really care about the amplitude. What we're concerned about is the THD. You can see the THD is about 0.019%, or about 0.02. And that's just not good enough. Now, if we set the amplitude of our oscillator here for 1 volt, and we set the frequency at 1 kilohertz, well, let's see what the difference between these two are. So here's our Keithley on top, and then here is the oscillator built into this unit. And this is why I paid so much for it. Okay. So you can see we have, again, almost double the voltage because we're not terminated. But more importantly, take a look at the difference here. That is why I paid so much for this. This is 0.000, about 1. Just about right. It's a little lower than the 0.0001%. You pay for this kind of accuracy. And as I said, I paid more for this unit than everything else on the bench combined. It was that important to me. And as I often laughingly say, it's pointed out problems that I would never have known I had otherwise. But if you're working on something that belongs to somebody else, I feel you should know what you have and make sure that it meets the specs that it was originally designed to have. And that's why I paid so much for this unit, because in the end it was worth it to me. So here's the whole difference right there. The Keithley has an excellent measurement section, and if I could have bought or built an oscillator, but I wanted an all-in-one solution. And one of the big things I really like about this is the fact that it tests both channels at once. Something that many analyzers don't do, yet many stereos are rated. Their specs will read X amount of watts, both channels driven. That's a big deal. So it's very important that we have the ability to do that. So I want to show you a couple of other things on here that have caused me a little bit of grief because I didn't understand what was going on. And one of those things is down here. We have earth ground or isolated ground. And I got messed up on this because I didn't understand what was happening. So I'm going to back up a little bit here because you need to be able to see something. This switch is currently set to isolated ground. So if I slide it to earth ground and I put my meter in here, here's earth, and we go to the shell here, and sure enough we have 0.2, 0.3 ohms, essentially right to earth ground. So if I go to isolated ground, that should go away. But it doesn't. And that messed me up because I couldn't understand why it was doing that. until I realized that this unit is connected to my scope. My scope is tied to earth ground. And if I take these off and I check it again, now you see we have total isolation. So you need to be careful if you have an oscilloscope connected to this thing, because you will not have an isolated ground. You will have earth ground. So that's one of those things you just have to watch. You can get burned by not understanding exactly what's going on. Okay, so I want to talk a little bit about the dummy loads that I put in here. I have a left and right channel dummy load. These are good up to 1,000 watts. And here's a diagram of how they're internally wired. I have banana jacks on the front to connect the speaker outputs from the amplifier under test. These leads come right from the dummy load, and underneath in the back are these. These come out of the dummy loads here and go into the input of the analyzer. So to recap real quickly, the amplifier input goes here, the dummy load is across these terminals, and out of the back come these guys, and they connect up to the analyzer. Also coming out of the back of the analyzer, we go into my oscilloscope. I like having a scope on here because then I can see when I reach the point of clipping. Now I could watch the analyzer, but it just wouldn't be as accurate. Other thing I want to show you is I made these guys for use with this analyzer, because as I often say, when you're dealing with that low a level of distortion, everything matters from the cables to the phase of the moon. I brought these ridiculously expensive Nutric connectors to go on here, and they're just really good quality cables. I'm not a cable guy as far as audio goes, but with measurement equipment, cables do make a difference. So I'm going to hook this up to the amplifier, and even though you see me use this many times, I'll just give you a demonstration. And we'll pay attention to the analyzer and not so much the scope or the unit under test. So I'm going to connect these up. I have a patch panel here that makes it convenient for me to use all these things. All right, and we turn the amplifier on. The amplifier is up at the top of this pile here. I'm not even sure if you can see that. Here we go. It's a Harman Kardon HK770. I haven't done anything to it. It's bone stock. It's just my bench amp. So we're going to go back here and we're going to look at the analyzer. So I'm going to zoom in a little bit. All right, that should be good. So we got to feed some signal in. The amplitude I'm going to start at 100 millivolts. Now remember, it's not terminated, so I'm actually getting 200 millivolts. Nevertheless, you get the idea. All right, so we have signal. You can see on the scope we have signal out of both channels. And now we need to go through the menu here, our measurement section, and change our units. Because currently we're reading volts because we were feeding, I wanted to see the voltage output of the sine wave oscillators. Now we want to look at wattage. And it calculates wattage because we put the factor in for our dummy loads, 8 ohms. So if it knows the voltage and it knows the resistance of the dummy loads, it can calculate what the wattage is. So if we prove our digit selector here, and I go right to the most significant digit, I can crank it up 100 millivolts at a time. I got 200 there. So we're about 20 watts. I believe this thing's good for, what are we, about 100 watts a channel, 90, somewhere in there. Okay, we're just starting to clip, and that's why I like having the scope there. This may be a 60 watt a channel amp, because you see quite a bit of distortion there. Okay, about 65 watts a channel. We're going to move the digit selector down. Yeah, it's just starting to clip here. You can see, if you can see the bottom of the waveform on the scope. Again, that's why I like having a scope on here. All right, once we get down below the clipping, you can see our distortion drops a lot. 0.2% is probably high for this amp, but again, it's bone stock. Just my bench amp, doesn't have to be anything special, just needs to make sound. Okay, so we need to make sure that our shift key here is off so that we're accessing the functions here at the top. So this is distortion, which is, if you recall, THD plus N. So what we want to do is we want to go and select our signal to noise. This is going to put signal on there, and then it'll take it off and calculate. So we have signal. Now the signal is off, and that will calculate the signal to noise ratio on each channel. And there it is. It's 108.36 or 108, 107 dB. We'll just call it 108 to be safe. I haven't looked up the specs, and again, the amplifier is bone stock, but that's how it works. So anyway, I'm going to call this video now. I enjoyed making it. I hope it answered any questions you had. If not, please place them in the comments, and I may make an additional video or at least explain what your question may be. But again, as always, thank you for watching this. And as always, I like giving back to the community that's given me so much. Thanks a lot, folks.